Hey everyone, it's Miss Berry. In this video, we're going to be going over addition, subtraction, and estimation with rational numbers. Alright, so let's talk about where will you be using this. In Georgia's math standards, we're seeing addition, subtraction, and estimation with rational numbers in grades 3 and up. And same thing with our Common Core standards, we're seeing addition, subtraction, and estimation come up in grades 3 and higher. We're going to start with addition and subtraction of fractions with like denominators, so whose denominators are the same. In this scenario, you are going to add the numerators and your denominators remain the same. All right, so let's take a look at our first problem. We have add 2 over 5 plus 1 over 5. You could also read this as add 2/5 plus 1/5. So I'm going to demonstrate this with a visual model. I'm going to take a little circle graph and I'm just going to split it up into 5 equally sized pieces. And then I'm going to shade in 2 of those little slices. That's going to represent 2/5. Right, then I'm going to add to that another circle graph. This time I'm going to represent 1/5. So I'm just going to shade any of my little slices to represent 1/5. And then I'm going to combine those to get my sum. All right, so I've got 2 slices shaded on the first circle graph, 1 slice shaded on the second circle graph. So if you put those together, then we've got 3 slices shaded. Sorry, I'm struggling with my computer today. All right, so we've got 3 out of 5 slices shaded. There we go, there's my third slice shaded. All right, so we've got 3 out of 5 slices shaded, or 3/5. So once again, if you were just using the standard algorithm, you would just add the numerators, denominator remains the same. So 2 plus 1 is 3, 5 remains the same. So next, let's look at a subtraction problem. This time I'm going to use a bar model. So this problem says subtract 7 over 10 minus 4 over 10. Again, you could read this as 7/10 minus 4/10. All right, so I'm going to use a little bar model. I like using these if we're working with a denominator of 10. All right, so here you can see I've got a bar and I've split it up into 10 equally sized pieces. I'm going to start by shading my first piece, so 7/10. I would shade 7 of those blocks, 4, 5, 6, 7. And then I'm going to take away 4 of those blocks. So I'm going to take away 4. All right, so when I take those away, they're going to disappear, and what I have left over is my difference. So that's 3 out of 10 blocks shaded. So 3 over 10. And once again, if you were just using the standard algorithm, you would subtract the top. Denominator is going to stay the same. So 7 minus 4 is 3. The 10 remains the same. All right, so let's talk about how we convert fractions to mixed numbers. If you recall, an improper fraction is going to be a fraction where the numerator is larger than the denominator. Some schools, some programs that you may encounter in the future, they may ask you to not call them improper fractions and to instead call them fractions greater than 1. All right, so just depending on what institution you're teaching at, they may want you to call them improper fractions or fractions greater than 1. All right, and then we'll also take a look at mixed numbers. All right, so again, an improper fraction is where the numerator is greater than the denominator. And our mixed numbers are where you have a whole number and a proper fraction, or a fraction that's less than 1, represented together. All right, so once again, just to further emphasize, a proper fraction that's where the numerator is less than the denominator. All right. So let's talk about how we convert those. All right, so we're going to convert 5 over 4 or 5/4 to a mixed number. All right, so let's say that we have represented 5/4 here with the bar model. So we've got 1/4, 2/4, 3/4, 4/4, and 5/4. I'm just going to come in here and match up with my little fraction strips, match up the one block. I'm going to say, okay, well, those represent 1. I'm just going to scoot my 1/4 down, and I can see now that that is 1 1/4. All right, so fraction strips make converting in between improper fractions and mixed numbers really easy. So really good use of that manipulative. All right, let's look at 21 over 4. We're going to convert that to a mixed number. Right, so you could do this using long division. So I'm going to show you how to do it with long division here. You would divide 4 into 21. Here you would say, okay, 4 goes into 21 5 times. 5 times 4 is 20. So just using my standard algorithm for division here, subtracting 20, that gives me 1 for my remainder. And then my quotient up here becomes my whole number part of my mixed number. 1, which is my remainder, becomes my numerator. And then 4, which is my divisor, becomes the denominator. So I'm going to write that down. So the quotient becomes the whole number part. The remainder becomes the numerator of the fraction part. And then my divisor becomes my denominator. So that becomes my denominator of the fraction part. Okay, so putting that all together, that's going to be 5 1/4. Okay, once again, struggling with my technology here. There we go. If you need to write that down, you can go back and pause the video. Sorry. Right, so 5 1/4. All right, so here we have convert 3 1/4 to an improper fraction. So this time we're going the opposite direction. So we're starting with a mixed number. We're going to convert it to an improper fraction. You may remember this from school. I always thought of it as like kind of going around the world. So you start with the denominator, multiply that to the whole number part, then add the numerator, and that all goes over the original denominator. So that would be 4 times 3 is 12, plus 1 is 13. That would be 13/4. All right, so let's talk about how you could do this with the fraction strips or a bar model. So you would say, okay, I have 3 whole or like 3 of the one strip since I have the whole number is 3, and then I've got 1/4 for my fraction part. And then I'm just going to take each of these and convert them into their little common denominators. So I'm just going to replace those with the 1/4 pieces. And then I can just count them up. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13/4, just like we said before. All right, 5 2/3, we're going to convert that to an improper fraction. All right, so again, here I'm just demonstrating the around the world technique. So you start with the denominator, you multiply that times the whole number part. So 3 times 5 is 15. Then you add the numerator. So 15 plus 2 is 17. So 17/3. So the denominator remains the same. All right, and now we have a negative number. I just wanted to show you what happens if you have a negative whole number part. This one will mess people up sometimes. So you're just going to follow the same technique. So start with the denominator, and then you multiply it times the whole number part. 5 times negative 10 is negative 50. Negative 50 plus 2. Right, so be careful there. Negative 50 plus 2. Not going to be 52, right? It's going to be negative 48. So negative 50 plus 2 is negative 48. Denominator remains the same, so negative 48 over 5. All right, so let's talk about how you add and subtract fractions when they do not have a common denominator, so when they have unlike denominators. This is the general formula. So if you don't want to talk about common denominators, you can just teach your students this general formula. You may feel like it looks kind of similar to cross multiplication, so that may feel like what you're doing here. And what's really happening here is just you're saying, okay, I'm going to multiply this numerator by this denominator, and I'm going to multiply this numerator by this denominator, and then I'm going to multiply the denominators together to get a common denominator. All right, so you're really going through the same process as you would if you were doing this old school style, finding a common denominator, but this is more algorithmic in nature. All right, so here's our little formula for addition, and we're supposed to be adding 2/3 plus 1/4. We see that the denominators are not the same, so we're going to apply this little formula. All right, so you can see I'm just multiplying. 4 times 2 is 8, 3 times 1 is 3, then I'm multiplying those denominators together. 3 times 4 is 12. Then I'm just finishing this up, simplifying in the numerator. 8 plus 3 is 11, so that's 11/12. Right now we're going to do the same thing for subtraction. So you're going to take, we're going diagonally here, so you're going to multiply those guys, then multiply these guys, then multiply the denominators together. So let's see, that's going to be 6 times 2 is 12, 5 times 1 is 5, so it's going to be 12 minus 5, and then 6 times 5 is 30, so that's our new denominator. 12 minus 5 is 7, so that's 7 over 30. I like this algorithm for addition and subtraction. It kind of makes it very quick. All right, here we've got some application problems. Jada made an apple pie. She used 11/12 of a tablespoon of cinnamon and 1/6 of a tablespoon of nutmeg. How much more cinnamon than nutmeg did Jada use? All right, so we're trying to figure out how much more cinnamon she used. So we're just going to subtract cinnamon minus nutmeg and see how much more cinnamon she had to use compared to the nutmeg. All right, we're just going to use our little algorithm from before. 6 times 11 is 66. 12 times 1 is 12. So we're doing 66 minus 12, and then our new denominator 7, or excuse me, 12 times 6 is 72. All right, so if you wanted to do it with the little algorithm like we just learned, you would do 66 minus 12 over 72. 66 minus 12, let's see, 6 and minus the 1 is going to be 5. 6 minus the 2 is going to be 4. So 54 over 72. All right, and let's look at it with the bar model. All right, so we're taking 11/12. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you see we have 11 of the 1/12 pieces, and we have one 1/6 piece. So if you had your little fraction strips, you could line these up. You would say, okay, I'm taking off 1/6, so I've matched that up. That's 2 of my 1/12 pieces. I'm going to take those away. And let's see what remains. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9/12, which is the same as the 54 7 over 72. So if you simplified that, you would get to the same answer. Pretty cool. Right here we have another word problem. It says Rhonda mixes 1½ cups of sand with 2 2/3 cups of potting mix to prepare soil for her cactus plants. After mixing them together, how many cups of soil does she have altogether? All right, so she's using 1 1/2 cups of sand, 2 2/3 cups of potting mix. So you're just going to start by combining the whole number parts, and then we'll combine the fractional parts. You can use your little algorithm if you want, or we can use the fraction strip model. All right, so we already know that we have 1 plus 2 is 3 cups. Now we've got to add the fractional pieces together. All right, so using our fraction strips, we have 1/2 plus 2/3, so 2 of the 1/3 pieces. All right, we can match that up with a 1 piece and see that that almost takes care of everything. We're just missing a little chunk there, and you could use your manipulatives to find out which chunk matches that little size, and that's 1/6. All right, so our fractional pieces add up to 1 1/6. So we've got 3 plus 1 1/6 gives us 4 1/6. So altogether, Rhonda's got 4 1/6 cups of soil. All right, here's some estimation problems. It says, suppose that we need to double a recipe that calls for 3/4 of a cup of flour. Do you think we'll need more than a cup or less than a cup of flour when we double the recipe? All right, so definitely more than a cup, right? 3/4 of a cup is almost a whole cup, right? So we only would need 1/4 more to get to a whole cup. So if we were to double that, we would for sure have more than a cup. All right, so benchmark fractions. These are commonly used fractions that are easy for students to visualize and identify. So here are some common benchmark fractions that you could see used. So we have 1/2, 1/3, 1/4, 2/3, and 3/4. All right, so here's an example of a problem where we might want to use those benchmark fractions. It says a 6th grade class is collecting cans to take to the recycling center. Becky's group brought the following amounts in pounds. About how many pounds does her group have altogether? All right, so here are our weights that we have. We have our whole number parts, so 1, 3, and 5. You can go ahead and add those together and say 1 plus 3 is 4, plus 5 is 9. So we definitely have over 9 pounds. Looking at the fractional pieces, 1/8, that's very small. We could say that's approximately 0. 4/10, that's very close to 1/2. So 4 is almost half of 10. It would have to be 5 to be exactly half, but we're just estimating here. 7/8, that's very close to being a whole, right? So 8/8 would be a whole. And then 6/10, once again, that's very close to 1/2. So if we were just estimating these, we would say that if we added these up, that would be about a half, plus another half, plus a whole. So that would be about 2 pounds. All right, so if we add that to our previously added up sum, so we had 9 plus another 2 gives us 11 pounds that we're estimating for her class. All right, and then here's our last problem. We're going to estimate 27/13 plus 10/9. All right, so we know that 13 times 2 is 26, so the numerator is almost double the denominator. It's actually a little more than double the denominator, so we know that that's a little bit more than 2. So 27/13 is a little more than 2. And then for this fraction on the right, 10/9, 9/9 would be 1, so that's just a little more than 1. So if you have a little more than 2 plus a little more than 1, you're going to have a little more than 3. So it's about 3. We know it's a little bit higher. All right, guys, that's everything for this video. If you have any questions, please let me know, and I'll see you in the next one.